All right, hello everyone. Today we're solving LeetCode 46, permutations. Given an array of numbers of distinct integers, return all possible permutations. You can return the answer in any order. So first, what is a permutation? According to LeetCode, a permutation is a rearrangement of all the elements in an array. And as you can see in the first example here, we have the numbers 1, 2, 3, and the output is all of the arrangements or orders of the numbers 1, 2, 3. All right. So now you know what a permutation is. How do we generate one? And we can actually model this through a decision tree. Let me zoom in so you guys can see. All right, let's imagine we start off with an empty array. Now from the empty array, how many options do we have? We have 3 because there's 3 numbers to pick. So let's say we chose number 1. So now we have an array with 1 element. So since we chose 1, that means that from this point forward, we only have the option to pick 2 and 3, right? Because 1 has been taken. From 2 and 3, what options do we have? We can either choose the 2 or choose the 3. If we go down and choose the 2, we'd have an array of 1 and 2. And if we went to the right side of this tree and chose the 3, we'd have an array of 1, 3, right? And from this point, the number of options decreases by 1 because we chose the 2. That means it's no longer an option. So the last number we can pick is 3. And on the right-hand tree, since we chose 3, 1 and 3 are no longer options, so the remaining element is 2. We go down one more time. Since there's only 1 option left, we only have 1 branch. So now we'd have 1, 2, and 3. Same thing on the right side. We use the last element, so we have 1, 3, and 2. And this would be the decision tree just for the number 1. But since there's 3 numbers, we could also start with number 2. And there's also a branch for starting with number 3. And you follow the same exact pattern for both of those. So the decision tree shrinks every level you go down because there's 1 less element you can choose. And for complete, I'm not going to draw out the whole entire tree because I respect your guys' time, but you can follow this intuition and draw out your own tree. I'm sure it will help you. It helped me quite a bit. And so now you know how the decision tree works and what we're going to be doing. Let's go into the time complexity of generating all permutations. It would be big O. Let me draw it so you guys can see it. It would be big O of n factorial. You may say, why factorial? Because at the first tree, or the first level in this tree, we had 3 options, right? We could either chose 1, 2, or 3. After we pick one, it goes down by 1. After you pick the second number, we only have 1 level left, so there's only to have the 3 to choose. So every level it goes down by 1, so it's 3 options times 2 options times lastly the 1 options. In this case, that would be 6. And so 3 factorial would be 6, and you scroll up and let's look how many permutations do we have? 1, 2, 3, 4, 5, 6. Perfect. All right. So now we're going to go into how we code up a solution like this. My approach is, since it says that all of the numbers in the array are distinct, so we have 1, 2, and 3, we can have an array of all true values. So let's say we had true. Well, let's just put T for true, right? So T, T, and T. And what we're going to do is have a regular DFS function. And in order to check what numbers are available, we're going to check the array and say, hey, does index 1 in the array, or index 0 in this case for the first element 1, does it have a value of true? If it does, that means we can use it and append it to our current permutation, right? And after we use it, we change it to false. So we erase this and change it to false. So now it tells us that the next iteration will say, hey, is 1 available? It's false, so we don't choose 1. It's going to go to the next element. Is index 1 available? Representative 2? It is. It's truthy, so we'd add that on. So that's how you can tell if we have a number available. All right, so what I like to do first is have a res variable, because res is just going to equal the container where we're going to store our permutations. As you can see, the output is a 2D array, so we need something to store it in. Second, I want to create I call it a check array, and it's just going to be a bunch of trues times the length of nums. And this is just the key to tell us if we have a number available or not. So the length of nums, right? After this, we can create our DFS function. So def DFS, and it's going to take in a perm. This perm for short for permutation. And since it's DFS, we know this is a recursive algorithm, we need a base case. So the base case is if the length of perm is equal to n. I didn't make the variable n, but n is just going to be the length of nums. And we do this because if the permutation is of length n, i.e. like 3 in this case, we want to append it onto our res because that means it used up all available elements, and this is a full reordering of the original number array, right? So if it's of length n, we want to say res.append perm, and make sure it's a copy because arrays are stored by reference, so we don't want to modify it. Next, we need a for loop to iterate through the number array. And think of it iterating through a numbers array. First, it chooses 1, and we're going to call DFS to go down that path. Then it's going to call 2, go DFS to go down that path, and 3. And then after we're done, we've explored all paths, and res should have all of our permutations. So I say for I in range n, so it's going to loop through 0 to n, or the length of the array. And the first check we have to do is say, well, is the number at index I available? How do we check that? We say if check at index I, so if it's truthy, we're going to say perm dot append, and since check at index I represents nums at I, we say nums at index I, right? So it's just like we go through and we say, hey, the first number is number 1. Is it available? If we had our truth array, it would be true, true, true. It is available, so we got to use it, add it to our permutation, so that's why we have 1 here, and then we have to change it to false because now it is unavailable, right? So perm.add nums, so since we used it, now that is false, so check at I equal false because we don't want to use in the next iteration, and now we're going to call DFS. So DFS with our perm with the add number we just added, right? When this function ends, that means we've explored all paths that start with, in this case, the 1. So what do we do now? Well, if we've explored all the paths that ends with 1 or start with 1, we don't need it anymore. So we can say perm.pop because we want to pop it off so we can explore new paths. And if we popped it off, that means it's now available. So we say check at I equals true. Perfect. And now all we have to do is actually call the function. So DFS with an empty array and return res. Let's zoom out and let's actually play it. Let's see how we did. Nice. And there we go. We solved it and it's relatively efficient. I hope you learned something new here, and drop a like if you enjoyed the video. Peace.